Okay, geometry students, I appreciate you finding time to do your notes. As I promised in class today, we are getting ready to kind of change our discussion a little bit. We're going to be spending a bunch of time looking at what it takes for triangles to be congruent. Now, we've already seen what it takes for polygons in general to be congruent, but what you're going to find with triangles is that there's a little bit of a shortcut that can be applied. Okay, so let's take a look. Our objective will be the student will apply triangle congruence postulates to tell if pairs of triangles are congruent or not. The date for tomorrow's class, Friday's class, will be November the 8th, so please write down your objective and the date. As always, press pause anytime you need more time to copy something down, and then hit play when you're ready to move on. Now, as the objectives suggests, okay, these shortcuts, they are also going to help us not only to tell if two triangles are congruent, but also help us to decide if we do not have enough information to decide if two triangles are congruent. There are 4 of these postulates. We're going to break it down into 2 days, so we're going to take a look at the first 2 and then the next 2 over the weekend. Okay. Now, just like with many other topics in geometry, triangles are of special interest when it comes to studying congruent polygons. Now, the only thing that makes triangles so special is that there are so many relationships going on inside of them between their angle measurements and their side lengths. Okay, and those relationships, since they are there and there's so many of them, it makes them very predictable. Okay, so triangles carry certain properties with them that allow us to predict their congruence based only on select pieces of information. Okay. The postulates we're going to look at today and next time, as I said, can greatly cut down on the amount of work that is required in order to say that two triangles are congruent or not. It is going to involve taking the information that we are given and comparing it to the postulates to see if one will work or not. Now, the general trap that geometry students want to fall into is that they think that, okay, we have these 4 postulates and one of them must work. Okay, and that's not true. One of these postulates does not have to work because, generally speaking, we do not have to have 2 triangles that are congruent. Okay, we're simply saying if they are congruent, we may have some shortcuts that can get us from the beginning of the problem to the end of the problem without having to prove that every single set of corresponding sides are congruent and every single set of corresponding angles are congruent. That's what we've had to do for polygons, but triangles are special. Okay, press pause if you need more time on this screen because I'm about to go to the next one and look at the first postulate. Okay, the first postulate is going to be the side-side-side congruence postulate. Okay. Now, guys, keep in mind, if you have forgotten what a postulate is a mathematical statement that is accepted generally without a lot of proof. Theorems require tons and tons and tons of proof. Postulates are more common sense. When we look at a problem and say, hey, this is the only way it can work, that's going to make it a postulate. Okay, well, the side-side-side congruence postulate says that if 3 sides of one triangle are congruent to the 3 sides of a second triangle, then those triangles are going to be congruent. Now, that may sound very similar to what we were working on with polygon congruence. Okay, so if you're wondering how this is different with triangles than it was with polygons, well, the difference is, if you're paying attention, okay, we do not need to know anything about any of the angle measurements with the side-side-side congruence postulate. It is only the side type information. Now, I will always give you a diagram of some kind when it comes down to a new theorem or a new postulate or something like that. Okay, so I'm going to give you just a generic diagram. This one is utilizing tick marks to show us that for every side length on the red triangle on the left, there is a matching side, a corresponding side that is congruent to it in the triangle on the right. Okay, and as we stated, you do not need to know anything about any of the angle measurements in order for the side-side-side congruence postulate to work. So if you can prove you have all three sets of corresponding sides are congruent, and a problem may not use the tick marks, it may use measurements, maybe we have to solve for measurements, whatever, but if we can prove that all three sets of sides are congruent, then we can state that in this case, triangle ABC is congruent to triangle DEF by side, side, side. And yes, it is okay on these postulates for you to abbreviate these names. You don't have to write out the big 5-word name. You can just put side, 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 SSS. Now, we also have another postulate that we're looking at today, which deals largely with the sides, and that one is the side angle side congruence postulate. Now, very similarly, it says side angle side says if two sides of one triangle are congruent to two sides of a second triangle, and the included angles are also congruent, then the triangles are congruent. Okay. Now, if you read into that a little bit deeper, okay, and also the order that it's written, side, then an angle, then a side. That is the order that we will be looking for this information inside of our triangles. A set of sides, then a set of angles, then a set of sides. The vocabulary that describes that is, like it says in this definition, included angles. Okay, well, included angles simply means, as the definition says, angles that are between those two sides. And I'll show you a diagram for it here in a moment. Okay, but first let's state the obvious. In this case, with the side angle side, you do not need to know anything about the third set of sides or the other two sets of angles. Okay, so how will you know when you're looking at a problem if you would like to use side, 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 or possibly side angle side? Well, obviously the postulates use different information to do what they need to do. So it will depend upon what is available in the problem. Okay, so if all you have is side lengths, side, side, side might be the deal. If all you have is a whole bunch of sides and a few angles, well, maybe side angle side is the deal. Okay, and here's a generic diagram to go along with side angle side. Okay, you should be able to very easily see this included angle idea. Okay, you can see in both of these triangles cases, in ABC's triangle and DEF's triangle, that the angle that is in question, the angle that we do know, is positioned in between the two sides that we know to be congruent. That's what we call an included angle. Okay, so once again, even though we do not know anything about the third set of sides or the other two angle measurements, we can then state that triangle ABC is congruent to triangle DEF by the side angle side congruence postulate. Okay. Also, keep in mind when you go to name your triangles, remember that it does not matter what order you name the first triangle in. You can put the vertices in any order you want, but the second triangle must match the order of the first triangle's vertices. So you got to get the corresponding vertices in order. Okay, now next we're going to look at several possible examples. Some triangles and see if we can say that we have congruent triangles or not. Okay, so here I have 5 different potential diagrams. As you can see from the diagrams, and as you're scribbling them down real quick, you'll notice that we do not have very much information provided for us. Okay, but as you will also see, some of the old rules and tricks and definitions and theorems and all that kind of stuff we've come across during the year, it doesn't ever go away. It's always going to keep hanging around, and that's one of the things I've been warning you about geometry. If you do not learn even one definition along the way, it can hang around and haunt you all year. Okay, so scribble those down. Okay, I'm going to ask you to go ahead and press pause here in just a moment if you need more time scribbling them down, and then we're going to come back and see if we can add some math to this and figure out what's going on. So press pause now if you need more time to copy your diagrams. Okay, let's start off by looking at the pair of triangles at the top left. Okay, obviously we have two sets of sides congruent. Okay. However, neither one of our shortcuts on the triangles will allow us to just have two sides being congruent. We're going to have to know something else. Okay, we're going to have to either know the third set of sides in order to get side, side, side to work, or we're going to have to know a set of angles in order to possibly get side angle side to work. Okay, well, let's think about side, side, sides for a second. Okay, do we have any way that we know of to come up with the measurements of this third set of sides? None that I can think of. Okay, if we knew we had right triangles, we might be able to use Pythagorean theorem or something like that, but I don't see anything that would suggest we know anything about these measurements of those third set of sides. Okay, so how about angles? Are there any angle measurements that we might know or that we might know to be congruent in this picture? Okay. Well, how about right here? What about those two positions that I just marked? Are those two angles congruent to each other? Yes, they are. That's a particular type of angles that we've talked about this year, and their term is vertical. They are vertical angles. They are across from each other at an intersection. And the rule for vertical angles is that vertical angles will always be congruent. Okay. Well, if that's the case, now we have two sets of sides congruent and we have one set of angles congruent. If they're in the right order, we can use side angle side. Okay, so are they in the right order? Is the set of angles positioned in between the two sets of sides that we do know? Yes, it is. Okay, we have a set of sides congruent, then a set of angles congruent, then a set of sides congruent. Side, angle, side. Can you tell if these are congruent? Yes, we can. And whenever you use one of the shortcut rules, you have to state which shortcut rule you actually used. If you just put down yes, but you do not have enough information to prove it without a shortcut, you're automatically going to be wrong on questions like that. Okay, so make sure you get the reason why you're saying yes in there as well. Okay, how about the two triangles over on the upper right? Once again, we have two sets of sides congruent. So we're either going to need the third set of sides or we're going to need an angle measurement. Okay. Now, some of you may be tempted to kind of jump on the same train we were just on and say, oh, we have vertical angles in the picture, and they're right there and they're right there, so they're going to be congruent. And unfortunately, those are not vertical angles. Okay, vertical angles happen when two lines intersect and the vertical angles are across from each other. We don't have two lines intersecting, we actually have three there, and those angles are not across from each other. Okay, so no angle there. Okay, I do not see any reason to think that we can find the third set of sides for those triangles. And if we knew we had parallel lines in this picture, we might be able to use some of the postulates from our parallel lines and transversal theorems. But unfortunately, we do not know if these two sides out here and out here, we don't know if they're parallel or not. So that's going to leave us in a spot where we cannot really come up with any other angle information. So in this case, we would have to say, no, these triangles are either not congruent or we simply do not have enough information to decide one way or the other. Okay. How about the set of triangles that's underneath them? Okay, well, we have one set of sides that's being marked as both congruent and parallel. Okay, so there's one set of sides. Do we have any other side links being congruent that we know about? Okay, there actually is at least one more set of sides in there that we know to be congruent, and if you're not paying real close attention, you might miss it. How about this line segment in between those two triangles? Is it not the same length for both of the triangles since it's basically the same line segment for both of the triangles? It is. Okay, so we have two sets of congruent sides. Okay, now, what we'd be looking for next is either the third set of sides, which I do not see any way that we could possibly find out what's going on with the third set of sides without more information, okay, or possibly an angle measurement. Okay, well, let's have a look at the angle measurements here for a second. This time we have parallel lines. Okay, and connecting those parallel lines is a transversal. Okay, now if we have two parallel lines that are being intersected by a transversal, then what type of angles are those two guys that I just marked? They're on opposite sides of the transversal. They are in the interior space between the two lines. That makes them alternate interior angles. Okay, so let me erase some of this doodling I just did all over the picture. And alternate interior angles of parallel lines are always congruent. Okay, so using the information we have a set of sides, then we have a set of angles, then we have another set of sides. Side, angle, side. Yes. And since we said yes, and we are using one of the shortcuts, we absolutely must identify which shortcut we used. Otherwise, we're probably going to be counted wrong. Okay. How about the bottom left-hand set of triangles? Obviously, two sets of corresponding sides congruent. If we could find the third set of sides to be congruent, we would be good. Okay, is the third set of sides congruent? I believe that it is, for the same reason as the one we just worked in green over there. This line segment down the middle, is it not the same line segment for both of the triangles at the same time? Of course it is. We have all three sets of corresponding sides congruent. That is enough for us to say yes by side, side, side. And lastly, how about our little two skinny triangles down at the lower right? Okay, we have obviously one set of sides congruent. We have the set of sides that is between them is congruent because it's the same line segment for both triangles. And we also have a set of angles congruent, the little right angles right in there. Okay, so is this side angle side? We have two sets of sides. We have a set of angles. Could we say that they are congruent by side angle side? It would be awfully tempting to say yes. The problem is it is a no. Okay, where does side angle side want the angles to be positioned? Wants them to be between the two sides. Okay, well, if these are the two sides that we know, okay, then where would that put the angles? It puts them way down here in this little skinny part. Okay, that's where we would want the angles to be congruent, and I don't see any reason why we would know that those are congruent yet. So it's nice that we have these right angles back there. Unfortunately, they are in the wrong place. Side angle side does not apply. Okay, the only thing I can think of that we might be able to do is we do have right triangles. Is it possible to use the Pythagorean theorem on a right triangle to find out what we know about the third side length? Sure it is. Okay, so what we have is we have two sides in the top triangle that we do know, and in the bottom triangle we have the same two sides that we do know, and it's all congruent. So when you plug into Pythagorean theorem for one triangle, we're going to get some value. Okay, but then what happens when we plug into the other triangle with the Pythagorean theorem? Okay, if we've done our math right, we're going to get the exact same value. If you plug in two sides into the Pythagorean theorem and then the same two sides into the Pythagorean theorem, it's like doing the same problem twice. So actually, if we did real good math on this one, we would be able to say, yes, these triangles are congruent by side, side, side. But side angle side would be wrong because the positioning of the angle was not in that included spot. Okay, now some of this may sound a little bit difficult. You may be a little bit confused by it, okay, but it'll get a little bit better as we go through some practice problems. Okay, so please bring your notes with you to class tomorrow, and we will have a look at some of those practice problems and see if we can't figure it out. Have a good night.